video will be about factoring polynomials. To factor a polynomial means to take a sum of terms and to convert it into a product of terms, which is the opposite of multiplying polynomials. The first tool we use in factoring polynomials is called factoring out the greatest common factor, or the GCF. To do this, you take a common multiple of all of the terms of whatever you're trying to factor. So this is something like if we have a term a times a blob plus a times another blob plus a times another blob, what we can do to factor it is we take out the a, which is the common factor, and then what we're left with in the parentheses is the sum of all of the different blobs. We can make this more concrete by having actual terms. So let's say we have something like mn squared plus 3na plus 4n cubed times m squared. If we look at all three of these terms, we see that they all contain an n. This means that we can factor out the n, and what we're left with is m times n plus 3a plus 4n squared times m squared. Note that even though we have an m here and an m here, we cannot factor this out because this middle term does not contain an m. Another useful tool for factoring is grouping. Grouping usually works best when there are four terms and when they look something in the form of x times a blob, we'll call that blob 1, plus x times a different blob, we'll just call that blob 2, plus y times blob 1 plus y times blob 2. And here the blobs just represent any polynomial. So our first step is to group the first two and the second two terms. So we're going to group the blobs. I'm just going to start abbreviating B2 and B1 for the blobs. So B2, there's our first group, plus second group, plus y times B2. Alright, so next we're going to factor out the GCF from each of the groups. So if we look at the first group here, we see that they both have an x in common. So we can factor that out. And that leaves us with blob 1 plus blob 2. And we can do the same with the second two terms. We see that they both have a y, so we'll take that out. And that gives us y times blob 1 plus blob 2. And then we can use the GCF again because we see that both of these terms contain a b1 plus b2. So we can factor that out. And what we're left with is x plus y. And so now our four-term polynomial is factored as a product of two binomials. Now let's look at factoring quadratics. A quadratic generally takes the form of ax squared plus bx plus c, where a, b, and c are constants. So before we start the factoring, let's just play a simple number game. What if I wanted you to come up with two numbers, n1 and n2, such that n1 times n2 equals 14, and n1 plus n2 equals 9. You might think for a bit on this, and you could come up with the answer that n1 and n2 are 2 and 7. Now when you factor quadratics, the trick is to do something similar. You want to come up with two numbers, n1 and n2, such that n1 times n2 equals a times c, and n1 plus n2 equals b. And then you're going to rewrite the quadratic as ax squared plus n1 x plus n2 times x plus c. And we see that this is valid because, remember, n1 plus n2 equals b. And at this point, all you have to do is apply the rules from grouping that we learned in the last slide, and you'll be able to factor your quadratic. There's a shortcut method for factoring quadratics that lets you skip the grouping. So remember, we have a polynomial ax squared plus bx plus c. And I'll just make this more concrete by writing in actual numbers. So let's say 2x squared plus 9x plus 7. What you do is you think of two numbers that multiply up to a. So let's just say that I'll choose 1 and 2. Let me write them like this. And then you choose another two numbers that multiply up to c. So let's say I choose 1 and 7. And then the next step is to do a sort of cross multiplication, where you do 1 times 7 plus 2 times 1. And we see that this would give us 9. Now the goal of this is to try to get it so that whatever answer you get here is equal to b. In this case, we see that we got it on the first try. But let's pretend instead that the first thing I tried was actually a 2 and a 1 and a 1 and a 7. If I'd done this, then when I cross multiplied, I would have ended up with 2 times 7 plus 1 times 1, or 15. Now when I got the 15, I would have looked to see that this is not equal to the b that I want it to be equal to. And so then I would know that this does not work. And I would try a different combination of numbers until I got something that worked, like this. And now, all we have to do is take this set of numbers and make these numbers the coefficients of the binomial terms. So that would be a 1 times x plus 1. That's our first term. And then our second term would be a 2 times x plus 7. And that can just simplify to x plus 1 times 2x plus 7. If a equals 1, then things are a lot easier. Then that means we have something in the form of x squared plus bx plus c. All we have to do is think of two numbers, n1 and n2, so that they multiply up to c and add up to b. And then, when we factor, it's just x plus n1 times x plus n2. And we can skip all of the cross multiplication and grouping.